if they were to censor us, and think of the situation I've mentioned with the HackDefi protocol and how it was mitigated by the various parties, then would it be too far-fetched for me to say the jurisdiction can say to us, use whatever mechanism you've used to mitigate this and censor these wallets for me? In fact, I'll give you an even more not so far-fetched scenario where a certain jurisdiction can say to us, infra providers, give me a list of all wallets from this geolocation positions from this country, and that country. And take those, say, 10 million wallets and go to the stablecoin providers. Guys, for these wallets, can you freeze all the stable accounts in their wallets? That's why we have to be wary of centralization. That's why we have to increase our commitment to building trustless solutions. And the censorship comes so along with that. As much as those entities can do that to us, then if we're not going to be able to have alternative solutions, is the ecosystem going to end up being the efficiency layer of TradFi or FinTech 2.0? That's why we have to increase our commitment. So this infrastructure that we have, the EIP-7702 Infra, number one, it is free, courtesy of the Ethereum Foundation. Number two, it is so easy to integrate with VM library. Number three, it is built on the tried and tested ERC-4337 infrastructure. There is more to it. There is more to it because it uses the shared mempool. Shared mempool is built on Gossip protocol. What it means is when you have one user operation in the mempool, it will be shared amongst many mempools. And that automatically gives you redundancy. It eliminates a centralized point of failure. And quite a lot of our clients, especially mature Web3 projects, have been asking us, and institutional clients as well, have been asking us lately to have a service level agreement, SLA, with 99.9% uptime. By us using the shared mempool, we easily can achieve that because we eliminate ourselves being the centralized point of failure. There is an added incentive. We have censorship resistance. If a certain regulator or jurisdiction says, I want you to censor this wallets and this bundlers, and as a user, I don't care. I can spin up a bundler in this open source shared mempools and process my own transaction. So it is quite important. It is important, but the shared mempool has been out for over a year. The adoption has been slow. So it is a worrying point that we might be sleepwalking to a centralized disaster at some point. And wallets that use the 7702 to enhance their usability but used a centralized bundler, they're taking a backward step. Because you've got an EOA, you're choke holding it into one bundler. Even worse, those wallets that use relays, their own relays, which are centralized in nature as well. And this infrastructure is will be available on 7 chains, and it has a 24-hour support for any developer or projects that integrate it. You will get 24-hour support. And we have, right now, it's rolled out on 3 chains, Ethereum, Optimism, and Arbitrum for free, and a few wallets that have integrated it. So I will quickly show you a video, just a short video, where one of our partners, the Pillar X from Pillar Wallet, have integrated the 7702 infrastructure. In this simple use case, what it shows you is they upgrade the wallet, it takes not long, and to use 7702, then you can see the EOA being used to send multiple transactions to multiple addresses. In this case, one to a distinct address using USDC, another one sending ETH to another address, both of them sent on an EOA, and you can see the transaction then going through Etherscan, and Etherscan now do have a new tab that shows 7702 transactions. So this is just showing you how simple it is to use 7702 for your EOAs and have an enhanced user experience. Now, when I show you this simple use case, think of the more complex things you can do. Not just batching 2 transactions, you can do a whole lot more as a wallet. So my section is making the case for why we should use 7702 Infra, and my colleague Nikhil will take us through the infrastructure of this 7702 Infra and takes us through code use cases. So thank you. Take it over.
Yeah, thanks, Michael. So this is Nikhil. I've been working at Etherspot as a backend engineer. So I'm here to speak about the technical details of 7702. I'm here to speak about the technical details of. Can't hear. Hello? Hello? Is that better? Hello? Hello? Is that better? Okay, thank you. Yeah, I'm Nikhil, so I'm working at Etherspot as a backend engineer. So today I'm here to speak about the technical details of 7702, which involve how do you sign authorization, what does it mean to sign authorization, and what are the various steps involved when one has to send a 7702 user operation in specific, and most importantly, introduce you all to the Ethereum Foundation's new bundler infrastructure, which is built which is built using entry point 9, which uses entry point 9, and introduce you all to that infrastructure and discuss what are the various steps involved to make use of this free infrastructure. And a few key points to highlight on the infrastructure is that it's 100% free to use. You do not need any API keys, or you do not face any rate limits while you use this infrastructure. So it's 100% free to use. So yeah, we'll run a few user ops during the workshop to understand to get a feel of how the 7702 user operations work. How do you prepare 7702 user operations? How do you sign, and how do you make use of this infrastructure to send transactions for free? So yeah, that's the whole agenda for this workshop. So yeah, let's get started. So over here I have a flow diagram which gives a good understanding of what 7702 is. And also it also gives a gist about how the Ethereum Foundation's bundler infrastructure architecture is about, and how does the infrastructure uh, response whenever there are incoming 7702 user operations. So that's what this whole diagram is about. So assume that we have a EOA wallet connected to a dApp, which does not yet have the 7702 capabilities. Now the first step in any 7702 user operation is that we sign the authorization. Now what does sign authorization mean? The sign authorization means that you are allowing a already deployed smart contract address to delegate to it. So as soon as you sign the authorization for this particular smart contract address which is already deployed, that means the EOA is now no longer a regular EOA, it becomes a delegated EOA. So all of its characteristics can now take advantages of a smart wallet. So it's like it can make use of EOS with sign authorization, EOS can make use of advantages like batching the transactions, making use of paymasters and things like that. So effectively, and a delegated EOA becomes a smart wallet, but also be a EOA at the same time. So that's what sign authorization means. And how do we sign authorization is that we would need 3 things to sign authorization. The first thing is the nonce to which chain you want to connect to, and the second thing is the delegate address itself, and the third thing is the chain ID, nonce, and the contract address. These are the 3 things you would need. So once you sign the authorization, we get the RSV fragments for a ECDSA signature. So after that, the second step is to compute the 7702 auth tuple. So that again consists of all of these things along with the RSV signature. So that's what we call a 7702 auth tuple. And that's what the bundler recognizes, that this is a 7702 delegation call. So as soon as this is done, we prepare the user operation along with this 7702 auth tuple. And once the user operation is prepared, we get a hash out of it, and then that's just the regular 4337 flow. We sign on top of the user operation hash, and then that is sent to the bundler using eth underscore send user operation method, RPC method. So yeah, once that's done, the bundler recognizes that there is a auth tuple over here, and makes a type 4 transaction. So now what is a type 4 transaction? Type 4 transaction is something which includes a field called authorization list. So this is basically a different version of the 7702 auth tuple, which can have like multiple EOAs and which specifies what EOA is delegating to what. So that's how the whole delegation setup happens, and that's how once the transaction is relayed on chain, the actual operation what the EOA wanted to do, as well as the delegation, both of them happens in the single transaction. So that's how the whole 7702 user operation work. So now whatever I explained so far is if it is a standalone bundler, the bundler recognizes that this is a delegation call, and then 7702 user op, and then it relates to the chain. But what happens with Ethereum Foundation's bundler infra is a little different because of the shared mempool architecture that it follows. So Ethereum Foundation bundler infrastructure has like two components for it. So the first component being a proxy layer, which is again a bundler node. So what does this proxy layer do is uh, it accepts all of the user operations that's coming its way, and it would validate all of these user operations and save it to the mempool and relay it to the connected bundler peers. So it's like Ethereum Foundation bundler infra is not any other standalone bundler, but it has the capability to host a network of bundlers which are connected to each other with P2P, which uses gossip protocol, of course, to relay the user ops safe and securely to the connected bundler peers. So that's why that's how the Ethereum Foundation's bundler infrastructure eliminates the single point of failure risk. Also it increases the robustness and effectiveness of your user operations getting included on chain easily. So yeah, that's that. And then once this proxy layer accepts the user operation, they are then relayed to the all of the connected bundler peers, and all of the connected bundler peers would then again send it to the chain. So that's how this works, and that's how this is censorship resistant also, because the proxy bundler which receives the user operation does not bundle it and attempt to send it to on chain. This is because we need all of the participating bundler clients to have a fair chance to send the user operation to the chain, because of course bundlers also have a certain fee cut for the user operations which they relay on chain. So there needs a fair chance for all of the bundlers connected in this P2P network. So that's why the proxy bundler does not relay user operations on chain. It only validates it and relays it to the rest of the peers, and then the rest of the peers would then again compete each other to relay it on chain. So that's how it's censorship resistant. So yeah, that's all I had for this slide. Moving on. Yeah. So how do we integrate this whole infrastructure? The infrastructure is great, but then again, what are the next steps to integrate this? So Etherspot has provisioned a SDK called Etherspot Free Bundler SDK, which has a function called Create Free Bundler, which would create you a bundler client, similar to the public clients or the paymaster clients, whatever we create from. So this is just an extension of VM library, and also it's not really mandatory to use Etherspot's free bundler SDK itself to have access to the infra. Even without the SDK, you can still have access to the infra. It's just that Etherspot has provisioned a bundler SDK to abstract away the difficulties of creating the bundler client itself. That's all. And as you can see over the code here, there is a function called create free bundler, and then using this you would get a bundler client back. All you have to pass in is the VM chain definition to which chain you have to connect to. And like Michael said earlier, we support currently like 6 chains: Arbitrum, Sepolia, and Ethereum mainnet, along with their corresponding testnets. So these are the 6 chains which are being supported currently, and in the coming few weeks there will be more chains added as well. And yeah, this is how you create the bundler client. And also one more interesting thing to note here is that you can optionally extend this client to use for RPC actions as well. So it's not just the bundler client RPC, but it can also be used for your regular RPC RPC actions as well. So it's like you do not have to maintain two different URLs with one with one URL, one RPC URL. You will be able to manage all of your actions, all of your bundler actions as well as your RPC actions. So that's what this means. So yeah, moving on. So how do we send user operation after creating the client itself? So once we have the client, um, there is a once you have the bundler client, it's straightforward. If you can have a look at the code over here. So what I'm doing in the first step is that I'm checking if my EOA account is already delegated. If it's already delegated, then I do not have to sign authorization, because sign authorization to delegate your EOA account to a different address, it takes certain gas. It's 12.5K gas, I think, uh, gas units. So it's like 12,500 gas units you would have to pay for that gas. So if it's already delegated, then you do not have to sign authorization again, because it's already delegated. So that's the check I'm doing over there. So I'm checking if my sender code is already delegated, and the first marker which you see, which is OX EF0100, that's the 7702 initial marker. So if any EOA is already delegated, that would definitely have that marker, appended prior to its delegate address. So if that contains that code, then you do not have to sign authorization. After that, you just call dot send user operation using the smart account client. I'll get to the part wherein how you can create smart account clients later. And then you specify your batch of calls, whatever you want to do, and then that can be multiple. In this case, there's only one, but that can be multiple as well. And then you get the user of a hash back. So yeah. So yeah, now I'll be doing hands-on. So these are the links that you would need if you wanna follow along. Then you can use these. Uh, so yeah, this is the documentation link. The first one is the documentation link, which is hosted on docs.erc437.io. And then there is a GitHub example wherein it has various account-specific 7702 examples. So it's on my personal GitHub. It's Nikhil Kumar 1612, and you will find a repo called 7702 examples over there. So yeah, I'll be opening that. Uh, share screen. Yes. Thank you. Okay.
So,
So I'll first, I have the
question.
documentation open, which is on docs.erc4337.io. You will find a section called 7702 user op guide, which will have the necessary guide to
Wanted to ask if you could put the slides links again, just for taking a picture and follow on
Yeah,
along.
sure.
Thanks.
Can you put the slide links again?
Okay.
So they want to take pictures. They just want to take pictures.
Okay. Cool. Oh, yeah, I have the documentation open. You will find a section called 7702 user of guide, which should have the necessary information for you to get started. As you can see, there is the first step is to install the Etherspot free bundler SDK. And by the way, in this workshop and in this demo, I'll be showcasing how do you access Ethereum Foundation's free bundler infrastructure via the Etherspot free bundler SDK. But you can even choose not to use Etherspot free bundler SDK and still have access to it. So yeah, the SDK supports both npm and bun, so you can use whatever you are comfortable with or whatever your project fits best. So this is the installation step, and then I have the repository cloned as well. Yeah, this is the repository which contains 7702 examples. So I have it cloned already, so I'll be opening that.
I think it is actually possible to do it in a very cost-efficient way and have enough trustlessness.
Yeah, if you have cloned this, run npm i to install dependencies. After that, you are good to go. Uh, so I'll just create a new file called test.ts
Utility of AWS.
just to run a few examples, whatever is there on the documentation.
We want, security and trust.
So yeah, so the first thing is to get all the supported networks. So what networks does uh, the infra support? So to get to know that, I'll just copy over this.
Bridges, whether that's the L2 data bridges or third-party
Is
bridges,
this?
for that to
And
be
the second one is to get the bundler and the RPC URL for the chain which you want to connect to. Uh, Copy over this.
I want to share my personal experience.
I'll just add logs.
Other people's experience. So we had a need to move some of our treasury funds
Import.
from one chain to another, and we decided to use a cross section. So we tried with a small amount, use those like super fast.
Yeah, to run this, I'll run npx tsx src test.ts. So as you can see, these are the chain IDs which are supported by the infra, which is like we already discussed. It's Ethereum mainnet, it's Optimism, Arbitrum Sepolia, and the Optimism Sepolia. And notice that I don't know if you can see this. Is this better? Yeah. So notice that you can see the RPC URL over here. So this is the RPC URL which you can use to connect to the bundler as well as your normal RPC actions as well. So this is basically the URL. I did.
Just ask them if they can see it.
This is okay. Yeah, so this is the bundler RPC URL which you can use to connect to the bundler. Moving on. How do you create bundler client? I'll copy this piece of code over here, the common client.
For anyone, really, right? That's like the bare minimum for me, and maybe I should have done better because I don't.
So this is basically how you create the common client. You have the create free bundler utility function from the SDK. I'll use that. And for chain, I would say
You're like hanging somewhere in the middle, and yeah, it's not very comfortable experience, right? So I hope that
I'll import the chain to which I wanna use now.
let's say it's too big, and I should be able to permissionlessly walk away, right?
I'll use Optimism Sepolia for this demonstration. Yeah, I'll be using that here.
I think it's actually quite normal, right? Well, it's pretty rare, right?
We chain, and then notice that I'm extending this wallet client to use, to make use of it for all of my public actions as well as wallet actions. So yeah, this is how you create the common client. Once you have the common client, we'll next see how to send the user operation itself. Also, just to show that this client can be used for both RPC as well as normal bundler actions, I'll create a function main.
I can DM you in Slack and be like, hey, I get funds. Like, that's all.
And then I'll say
Do you think you're trustworthy? All that kind of
piece
stuff. But from Ethereum's perspective, like, if some other guy chose
supported entry points. Then say common client dot get block number maybe. Yeah. Block PS, then the block number. So notice that I'm doing two actions over here. One is a bundler client action, and the other one is the normal RPC action. So since the the hosted network, the hosted infra supports the common URL supports for both RPC and bundler actions, I should get the result for this. And I'll call this function. Again, I'll run it the same way. Yeah, as you can see, these are my supported entry points, and this is the block number which I get now for Optimism Sepolia. Moving on. Okay, so the next step is to construct user ops and understand how do we send user operations itself to the next section. Uh, so so from a implementation standpoint, there are three steps that you would have to follow whenever you are trying to send a 7702 user operation. So the first thing is to create the smart account client. In this case, we will be using the account abstraction simple 7702 account, which is fairly easy to use. So we'll be using that in the example. Uh, okay, I'll just copy over the function here. I'll just have these commented because I don't need them anymore. So this is how we create the smart account client itself. So then I need to have the owner. I'll get that.
Curious to know about if you think that the users are
And
aware
I'll
of the systems they're using the different types of systems. I guess it has to you, Joab. Is this something that you feel is clear enough
as
as
hex.
of today? You are
So
still,
I'll import the .env package so that it can read from my env.
higher cost when it comes to using these fully trusted systems versus using something that just
Can I ask a question? Because
Yeah.
I dabbled with 7702 before, and the issue that I encounter is that you always have to use a private key account to sign the authorization.
That's right.
You cannot use, like, there's no JSON RPC method
That's
to
right.
sign. Is it still the case?
Yes, yes, yes.
Okay.
Actually, there is a reason for that case also.
Okay,
There
yeah.
is a reason why JSON RPC accounts do not allow sign authorization.
Yeah.
Because ultimately, anyway, with Ethereum-based ECDSA signatures, it's anyway you are signing a hash. At the end of the day, be it sign type data or be it personal sign or be it sign message, you ultimately you would end up signing a 32 bytes hash. But with sign authorization, there is a security risk because like the attacker dApp or the dApp which you are trying to connect to might deceive you by giving you a hash which you can sign. If you sign that hash, that can be used to delegate your EOA account. So that's the main reason being why it's not allowed on the UI that you sign authorization. But it becomes at the same time it becomes wallet specific implementation. Like let's say you are using some wallet, that wallet would know that if I want to use 7702, that wallet would know to which account I have to delegate it to. So it would internally sign on behalf of you, but it's not presented to the user.
Yeah, exactly. Because like I've seen that like with 5792, the wallet send calls namespaced the wallet namespaced ERPC like, RPC methods like wallet send calls. The implementation of how to batch multiple calls is left to the wallet. And for example, MetaMask is actually using 7702, but it's doing it as part of the wallet. It has my keys. It makes me sign like I'm making an RPC request to the wallet. The wallet internally process it and say, oh, I need to make the user sign this thing. But like this is a walled garden because like first of all, it's left to the implementation of the wallet.
That's right.
Like your mileage may vary depending on which wallet are you using, and then it makes them more powerful. Instead, I cannot basically build a web app relying on the fact that the um, you know 7702 will be used or not. Like I actually want to be purposefully build a web app that leverages 7702, but at the moment because of the absence of the sign authorization method, I cannot. Right. So I don't know.
That's right.
Basically, I don't know how to get around these things. I don't want to hijack the thing. Maybe we can.
No, no.
Yeah.
Yeah, we'll maybe connect later because there's only 10 minutes
Yeah.
left.
Yeah. Absolutely. Yeah,
We
sorry.
can connect later. Yeah,
I,
that's fine. So yeah, moving on. How do we send the user of itself? I was in the middle of copying the private key and things like that. Some import issues. I'll do that. And then so this is how we create a smart account client. So in this case, we are using the two simple 7702 smart account uh, utility function from the VM itself, which will give you the smart account client back. And after using this,
Is like we're stuck with it, right? We will
uh,
expose these risks. The question is like, will people care? And maybe right now,
yeah. so the next step would be the same thing which we discussed on the slides.
With that, because they actually manage other
We'll
people's
add this
phones. And if something
and
goes
see if
really
there are any
wrong,
import
and
issues.
maybe you
Type.
run the risks, they could be sued for gross negligence or something. So
Sparse
maybe this is
units.
our hope, but I don't think the individual
Yeah, that's all.
users will
So
ever care
this is how you
understand
send the user
it,
operation. I'll run
right?
this
They will
now.
literally try to do the swap and hope for the best, and in most cases
Uh,
it works, and if it doesn't, then,
okay.
well, tough luck.
In many ways, would you agree, like every dApp that you
I
use
think
is
I'm missing my private key over here. I'll just grab my private key directly in this case.
DNS is secure, the core
Most,
database.
yeah, most. But again, I would say that there's a
Add this
difference if you
private key
trust
here.
the Uniswap code or some other version which is like completely.
So as you can see, this is my wallet address, which is both my smart wallet address as well as my EOA account address. So this is the user operation hash which I get back. So I'll try now and open this on the Explorer.
Right? We don't want the EOAs to be able to upgrade your contracts, and we first and foremost we want these risks to be.
So if I can head over to internal transaction, you can see that there was a transaction 14 seconds ago. So this is basically using the Ethereum Foundation's bundler infrastructure. Actually, it went to the RPC node, and one of the connected bundler peers took that transaction and relayed it on chain. So yeah, that's how you do it. And then moving on to the documentation section. So yeah, if you want to have your 7702 user operations sponsored, then what are the extra steps that you would have to take care? So I'll be speaking about that now. So all of the steps are still relevant even if you want to have it sponsored. The only extra step would be to create a paymaster client. When you are creating a paymaster client, you would have to add the paymaster URL. Of course, now I don't think there are any paymasters which is supporting entry point 9, given the entry point 9 is very recent. But once we have paymaster supporting entry point 9, we can use the paymaster URLs here and create paymaster clients. And then all we have to do is during the send user operation, just add the paymaster related details here, and then you'll be able to sponsor your 7702 transactions as well. Uh, so yeah, if you guys wanna like try out the Stack Blitz also, we have Stack Blitz integration also over here. If you can open this, this should like clone the free bundler SDK repo itself, which is on this GitHub over here. I don't know if I have it open. Yeah, this is here. So this is the free bundler SDK, whole repo, which has an examples folder and a like a usage MD file also, which you can use, which gives you like a minimal command line terminal which you can use to just try out 7702 user operations. So yeah, that's one way. That's another way of trying 7702 user operations. Okay. And then moving on now, I'll speak a little bit about account-specific examples. In this example, whatever we see here, we had a utility function from VM so that you could use that to create your smart account client. But what happens if you have your own custom wallet implementation? Because all wallet implementations are not the same. They behave differently. Like the signature schemes may be different. The way you sign user operations might be different. So how do you do it if you have a custom, 7702 wallet implementation? So I have a few examples on my repository over here. For the sake of, for the sake of this example, I'll be choosing Amber over here. I'll head over to send.ts here. So yeah, I'll try to give a walkthrough of what are the various steps I took to make it work for the wallet which I've chosen here, because VM inherently doesn't give you two smart accounts for all of the wallet implementations. So what I had to do over here is I had to create a smart account client myself by using two smart account VM library utility function from VM. So when you are creating a smart account client for your custom wallet implementation, you would have to specify all of the fields needed, like the entry point. This is the new entry point address, by the way. And then I'm using entry point 8 ABI itself because it's still compatible with entry point 9 also. And then because just to be type safe with VM, because VM doesn't know anything about entry point 9 now. So that's why I'm reusing the entry point 8. And over here also I'm specifying the version entry point 8 because VM doesn't know anything about entry point 9 currently. So just to be type safe, I'm using entry point 8. And then how do you encode calls? That's basically what goes into the call data field of your user operation. So that's that. How do you encode calls? How do you batch transactions for your particular smart account implementation? So that would have this details. And then decode calls, it's just the opposite of what encode call does. And the authorization, like your private key account which you just created, and then the implementation address itself. So this is the address which holds the the implementation details for your 7702 account. And then how do you get address? Because this is a 7702 account, the EOA address itself will be your smart wallet address also. And then how do you get factory args? This goes into the init code section of your of the user operation struct. And then how to get stub signature? Stub signature is something which will be used during estimate user operation gas call. So this is the stub signature which will be used. Uh, and then how do you sign message? All of the details. In this case, it will of course be using the owner private key account. And then how do you sign type data, which is 712 signatures? How do you do that? And then the sign user operation itself. So I convert the user operation to packed user operation to be compliant, to be compliant with whatever is there on Solidity. And after that, I'll get the user operation hash back, and then I'm decoding it because of the wallet implementation which I have chosen. This is all specific to the wallet which I have chosen now. And then I get the 712 data for the user op, and then I sign the signature and return it back. That's the implementation for sign user operation. And then yeah, rest of the steps remain same. You check if it's already delegated or not. If not, then sign authorization and then hit send user op. I'll try to run this now.
Design something that can compete with a fully trusted solution so that that is a viable,
Accounts.
you can kind of teach process to that kind of
Dot TH.
application.
So yeah, as you can see, previously I used the same account to use a different thing. So that's why you can see the the authorization over here. For some reason it failed. Let's take a look.
We still give you the highest rating. So if you can provide that, then I'll be like promoting your protocol left and right.
What about across?
Yeah, is trustless is, I want trustless to actually, like, I want to do things that the trustless makes the protocol better for its users. Like, it's not just a nice to have, it actually makes it.
I think there is a mistake on the delegate address which I used over here, but you get the idea. So that's how you use account specific examples to send user operations. So yeah, that's all I had. And moving on to the slides back, I had a slide on do's and don'ts of the you know uh, of 7702. So basically, it all comes down to the wallets, because they are the gatekeepers for your 7702 delegation. So it becomes very important on which wallet to trust and which delegation address they choose. And then the storage collisions, the smart contract developers for 7702 implementation, it becomes important because the address space is same, because it's the EOAs address space on which all of the code resides and the storage resides. So it becomes important for wallet smart contract developers to have actual logic or implementations in place such that the storages between multiple delegations do not collide. And then the broken assumptions like tx origin should be equal to message.sender, those are no longer relevant. Yeah.
Any questions?
Yeah. Do you guys have any questions? I can take questions now.
Yeah, we're out of time, but do you want to say something quick about this?
Thank you very much. We will answer your question offline. Yeah, we can. Yeah, you can just take it off and sit down.
I guess we can continue on what I was saying earlier. Like
Yeah.
the bigger question is like, how can we use this in a web app essentially? Because like in a web app, I'm connecting my wallet through the wallet connector, for example, and through that I cannot sign the authorization, right?
Uh, this is more of a implementation detail for wallet developers itself. Like let's say if there is some other XYZ wallet which is a browser plugin over there, and how do they sign authorization and then send 7702 user ops? If you are if your web app is relying on already existing Chrome plugins like MetaMask and all of that, then this does not become relevant to those, because MetaMask would have their own procedures or things like that to send transactions.
So if I add to this, ultimately, 7702 brings a risk in that, imagine you are a dApp and you say to me, can you delegate your account? And it could be a malicious dApp. So for that reason, when 7702 was approved, it was decided the wallets would be the gatekeepers, so that a wallet would say, unless we've got it on a whitelist, we cannot allow any smart contract to be delegated to. So obviously that brings the issue you've raised. I think, is it EIC
5792.
Yeah, so
the wallet send call.
exactly,
Yeah,
you
yeah.
can check with that. So if you're a dApp, you can check, is this EOA or is it smart account? Because basically, when you have a 7702 wallet, it satisfies the smart account. So it becomes onto the dApps on basically to have a fork EOA, smart account. Other than that, until we get enshrined, if this is opened, every EOA is going to get hacked. Think of the calamity.
Yeah, I get it. Yeah. It's just that, as you said, they become the gatekeepers, and so
Yes.
Um,
They become the gatekeepers. At least what we are arguing about is, do not send it to centralized bundler, because
Sure.
you bring in the EOA to a centralization and you are introducing a new risk. At least put it on the shared mempool. That's what we're arguing.
So yeah, I mean, I guess all I understood, even the security concerns, which are valid. But ultimately, like, what is your advice if I want to build a web app that, because I'm actually doing it, we're doing it with Compose, we're batching multiple calls, and as of now, we're using just ERC-437, but it's a pain in the butt because you need to move funds
Yeah,
every time.
exactly,
with the EOA,
exactly.
Right? Like this is, to me, this is the solution.
Yes.
But as a dApp developers, I cannot use it.
Yes, so
Right.
basically, for people like us, we have to evangelize the wallets to adopt 7702. Whether they use the shared mempool or even a centralized bundler, at least in terms of usability, it would address your concerns. Because
It's just like in the specific case we're on a test net, right? And so I cannot go to MetaMask and say, hey, please, can you deploy your delegation toolkit on my scrappy rollup that it's going to be live for another 2 weeks before we tear it down? Like, you know what I mean? So the whole thing that we're building is ephemeral by nature. And so basically, because of the wallet gatekeeping, I cannot leverage this, right? You know what I mean?
yes, I mean, not the specific infra. I completely agree with you. So when you talk about the MetaMask, they would only allow you whatever
Yeah.
they've rolled out.
Yeah, or I'm talking about MetaMask, but in general.
Yeah.
You know,
So what we are trying to do is we're trying to get more and more wallets to use the shared mempool. As soon as they do that, then it would be available on all infra supported.
Gotcha.
Otherwise, as you said, it would be up to that wallet to say, are we going to deploy our infra? So I do feel you. I do feel the frustration.
yeah. It's I think it. Yeah, it's just it's in a way it's a valid problem, but it's kind of separate because for me, like, my problem is the sign authorization bit, right? Like, because as you said it, like, for security reasons, it's like demanded that the wallet do it, but like I have to go through them.
Yes, they're the gatekeepers
Yes.
of 7702, no doubt.
And will
EOAs.
they remain, in your opinion? Like,
Well,
should they remain that
when
way?
we get to 7701 enshrined one,
Gotcha.
it would be protocol level. No one is the gatekeeper. You don't use the
All right.
bundlers, this, that, and the other.
7701.
Yes.
Okay.
So that would be the ultimate aim, to enshrine this into the protocol level.
Is there a roadmap for that? Did you know?
I think a couple of years or so, because it would require a hard fork.
Oh, okay.
So the whole point is trying to avoid the hard fork. Unfortunately.
No, I get it. Okay. All right. Thank you. Thanks
Thank
a
you
lot.
so much.
Good job.
Yeah.
Thank you.